The moment arrives without a sound. One instant, the sun hangs in the sky, a familiar blinding disk of life-giving light, the sun that has warmed our world for billions of years. The next, it is simply gone. The brilliant blue vanishes, replaced by absolute blackness. Stars, once hidden by glare, burst into view, cold and distant. Birds in mid-flight fall silent. The air begins to carry a subtle, chilling edge. We do not feel the profound cold immediately. The atmosphere holds heat like a blanket. The oceans hold heat like a blanket. Light from the sun takes just over 8 minutes and 20 seconds. Heat follows light, maintaining equilibrium. The sun is our anchor. The sun is our furnace. The sun is our clock. Now imagine that anchor is not just removed, but replaced. In the same seamless moment, something else takes its place. We will explore 5 distinct candidates. For each, gravity, temperature, orbit, radiation, and survival. We embark not out of morbid curiosity, but to appreciate our star. Our first replacement is the most common star in the galaxy, a red dwarf. These stars are cosmic tortoises, small, cool, incredibly long-lived. Far dimmer and less massive than our sun, sipping fuel for trillions of years, longer than the universe has existed. If a red dwarf of the same mass appeared, the first change would be the light. Day becomes a perpetual, deep twilight with a faint reddish hue. Brighter than night, but dimmer than a heavily overcast afternoon. Photosynthesis would falter for all but specialized plants. With the same mass, Earth's orbit remains unchanged. But typical red dwarfs are 10 to 50% of the Sun's mass, weakening gravity and widening our orbit. Our world would spiral outward to a colder path. Temperatures drop slowly but relentlessly. Glaciers advance. Oceans glaze with ice, thickening over years and decades. Life, depending on liquid water, faces slow-motion extinction. A snowball world emerges. Many red dwarfs are flare stars, unleashing powerful X-rays and charged particles. Flares could erode our atmosphere and irradiate the surface. Survival moves underground or under the sea, yet a red dwarf offers time, dim, steady, and long-lived. Master energy, food, and shelter, and we might endure for eons. In the first hours and days under a red dwarf, the immediate problem is psychological and logistical. Permanent dusk triggers panic and confusion. Power grids strain as every home, office, and street turns on its lights. For a person outside, the world feels alien. Home stolen and replaced by a dying ember. Warmth vanishes, replaced by a growing chill. As weeks turn to months, agriculture fails. Global food chains collapse. Survival depends on massive, artificially lit farms, likely powered by nuclear reactors or geothermal energy. New breadbaskets glow against the cold. Ice reshapes civilization. People migrate toward the equator. The most viable long-term strategy: move underground. Life narrows to tunnels, artificial lights, and recycled air. Dim as it is, a red dwarf grants a predictable decline and time to adapt. If we master energy, food, and shelter, our descendants may endure in perpetual twilight. Now imagine a far more violent replacement, a blue giant star. Titans, far more massive, hotter, and orders of magnitude more luminous. The sky would erupt in ferocious blue-white light, a searing presence, much larger in the sky. A glance could cause permanent blindness. The gravitational consequences would be severe. Blue giants often contain tens of times the sun's mass. Earth is yanked inward, spiraling toward a terrifying furnace. A year could shrink to weeks or months. Planetary orbits shatter into chaos and collision risks surge. Temperatures would skyrocket within hours. Ice caps melt in days, inundating coasts. As we fall inward, oceans heat and boil, wrapping Earth in scalding steam. The atmosphere swells and is blasted into space by radiation and stellar winds. Blue giants live fast, die young, in supernovae. A supernova's wave could vaporize Earth instantly. This scenario offers only a countdown to annihilation. We lack the means for interstellar escape on that timescale. Passengers on a world flown into a furnace. The end would be swift, total, and fiery, you know. The human experience would be one of immediate and escalating terror. The first moment, a flash so brilliant it feels like a blow. It would shatter glass and ignite flammables. Anyone outside suffers instantaneous burns. The human image, retreat to the deepest, darkest room. The air grows hot to breathe, the world cracks and burns. No time for a coordinated response. Days bring drowning coasts, yet heat is the greater threat. Civilization breaks down, grids overload, comms collapse, a desperate futile scramble for shade and depth. Oceans become a boiling cauldron of steam. The sky becomes a suffocating blanket of vapor. Forests turn brown, then black under relentless glare. All life, microbes to whales, would be extinguished. The planet becomes a scorched, red-hot cinder. Balance is everything. Our next replacement is a stellar ghost, a white dwarf, the dead core of a sun-like star, left after shedding its outer layers. Incredibly dense, sun's mass packed into an Earth-sized sphere. Initially white-hot, even bluish from residual heat. The sky dims, light is faint, ethereal, with sharp shadows. Same mass, same orbit. Earth keeps circling its tiny master. But the total energy output plummets. Tiny surface area. Earth enters a profound, ever-deepening cold. Much energy arrives as intense ultraviolet, harmful to life. Ozone protects but is constantly battered. A white dwarf is a dying ember. No fuel, only fading heat. Over millennia, oceans freeze. Air condenses and falls as crystalline snow. Humanity fights cold with geothermal warmth and machines. Quiet endurance. Technicians sustain the systems that sustain us. The sun's ghost becomes our diamond star, a celestial clock fading through eons. Centuries on, humanity lives on permanent technological life support. Securing near-limitless energy, fusion and enhanced geothermal, becomes paramount. Cities become sealed arcologies across vast plains of ice. Artificial suns power manufactured ecosystems. Farming moves entirely indoors. Oceans freeze solid, perhaps miles deep. A new ice continent covers 3/4 of Earth. The air turns thin and bitter. Nitrogen and oxygen snow blanket the world. Surface travel becomes a spacewalk in pressurized, heated suits. Earth, a silent jewel of ice and rock. Despite the cold, orbit is stable. Flares fade. We tap the planet's core for warmth. Self-sustaining domes thrive above the ice. Its slow fade marks eons, the sun's ghost as our clock. Time to adapt, innovate, or someday build ships to seek a new sun. Consider two extreme replacements: a neutron star and a black hole. A neutron star is city-sized and so dense a teaspoon outweighs a mountain. At our distance, gravity stays the same. Our orbit persists. But lethal X-rays and particle storms sterilize the surface. If it is a pulsar, sweeping beams fry the atmosphere on every rotation. A black hole of sun-like mass, surprisingly, leaves our orbit intact. Gravity is the same. Earth would not be sucked in. But the light and heat are gone, instantly. Cold grips the planet, relentless. You look up and see only a perfect black void. Survival means deep, shielded bunkers or fully artificial habitats. All energy must be generated, massive nuclear, even novel rotational schemes. The surface becomes colder than Pluto beneath eternal night. No flares, no stellar winds, no radiation, only gravity and dark. A neutron star kills with radiation, a black hole with cold. Our needs are exquisitely specific. Across all swaps, one truth is clear. Our sun is uniquely suited to us. Not the largest, not the smallest, not the hottest, not the coolest. It resides in a calm, stable middle ground, a Goldilocks star. Its mass holds predictable orbits without burning its fuel too fast. Its energy is strong enough to drive life, gentle enough to spare our oceans and air. Light changes in 8 minutes. Climate shifts unfold over weeks to millennia. Our atmosphere and oceans provide a crucial buffer. We can imagine mirrors, shades, and subterranean cities, but preservation is wiser. The sun gives balance freely, a gift billions of years in the making. We return to our familiar yellow sun with renewed gratitude. We live in a gentle eddy of a violent cosmic river. Our chemistry, water, and air are tuned to this one particular star. Stability allowed life to ask these questions at all. Out of all the stars in the universe, did we win the cosmic lottery?